Hello everyone, this is the second lecture in the series of our video. In the first series, I have shown how to extract Excel file, how we can simply plot data from the scatter plot, and very few statistical parameters that I have shown in there. This is the continuation of my first video. I will show here a few more statistics that you might be interested when you are looking in your data. So when we are dealing with a very unknown data, then we first want to know how the data structure is, what is the mean, median, mode, if there is any outliers or not. So for that we need to check the descriptive statistics in a data. So basically I will be dealing with that few statistics that usually we do while we see any data. So I will take the same Excel file that I have taken in my previous video. I'm in my desired location, as you can see, and I will extract this dummy data in my R console. So uh, I will take the XLS command, and then I will take the XLS file in the inverted comma, and then I will put the seat index, which is 1, and I will put this in object name A. Okay, so I will see what I have extracted, and I can see I have 6 columns, B, E, G, H, C, and D, and 11 rows. So for example, if you want to change the row name or row column, you can easily do that in R. Suppose I want to change the row name. Row name now is this one, 1 to 11. So I can put this as my row name. I have written it beforehand so that time doesn't just waste here. So I have taken a series from 1990 to 2000, and then I will just hit enter. Now you can see I have changed the row names. This is 1990 to 2000. Simultaneously, similarly you can do it for the column names also. So now as I have a set of data, I will be interested first to know what is the mean, median, mode of these 6 columns. So what you can see, I can just write summary, and then I can in the first bracket I can just write A, and what you will see, you can see the minimum, first quantile, median, mean, third quartile, and maximum of all this column has already displayed. So it is a very quick look of your data set, uh, that how your data looks like, what is the maximum minimum value. However, you can see that there are few things that are missing. Like if I want to see the variance, if I want to see the uh, you know uh, other quartiles, if I'm interested to see, then how we can do that. So we will just type a function called quartile. Sorry, yes, and then I will put the desired column. For example, I want to see the first column, so I have taken A1, and then suppose I want to see the for example, third quartile, or 75 fifth percentile, whatever you can say. So as you can see, it is 9241. So in the first column, you can verify it is 9421. For example, we are interested to see the 4. So this is 40th percentile, or 40th percentile, as you can see, it's 6591. So this is for quartile and percentile thing. Now if you are interested to see the standard deviation, you can just uh, write the SD. In R it is SD, and if you want to see the for example second column standard deviation, you can just write A2, and this is the standard deviation. So if you're interested for others, then you have to just change the column and you will get the desired standard deviation. uh, then if you're interested for the variance, you can just type VAR, which is variance of for example first, I will take the first column. So this is the variance of the first column. Now if I interested in the covariance of the two data set, then I will just write the function COV. It is for covariance, COV, and I will take, for example, the first two columns of my data set, and that will give me the covariance of the two data set. Okay. Next, if you are interested in interquartile range, which is basically the difference between the third and the first quartile, then you have to just type I in capital IQR, and you have to give the range that you are interested in. For example, I will give here the third column. So this is my interquartile range. And then if I interested in correlation, so correlation will be for this is core, COR. In R we do correlation with the function COR, and then I will just put A1, and for example I'm interested in the first column and the fourth column, for example. Okay. So my correlation is 0.95, which is quite good, and but you can ask me that whether this is significant correlation or not. Then you can just type core.test, and you will able to see your p-value. So it is, as you can see, the p-value is lower than 0.05. That means this correlation, this value is of course significant. So if you are simply interested in correlation, you can just do core of the two data series, and if you want to see the significance of that particular correlation, then you can just type core.test, where you will able to see the significance of your correlation, and this is the value, this is the degree of freedom, and this is the t-test. Okay, now the next thing, people are interested in the skewness and kurtosis of the data sets, whether it is positively skewed or negatively skewed. So to see the skewness and kurtosis of any data set in R, we need a package called moment. If you have the package, it's fine, you have to just do the library. If you don't have, you have to install it by install package, and you can write moments, and you can ENTS, yes, and then you can just hit enter. It will install in your R package, and then you can just do the library moments. Yes, as you can see, I have already moments, so it is automatically coming. So I am just doing this library, and then I will see the skewness of my first column. Yep. So it is 0.29, which is close to 0, which signifies that it is near Gaussian distribution, which is not, of course, it is not perfectly Gaussian distribution, but is near Gaussian distribution. The idea is that if you have a value close to 0, then it is completely Gaussian distribution, and if you have positive value far away from 0 value, it is positively skewed, and if you have negative value, then it is negatively skewed. Okay, I will also try to see the for example, fourth column skewness. Yeah, you can see it is negatively skewed as the value shows 0.31 something. So this is a negatively skewed value. And if I'm interested in second column, you can see it is more positively skewed than the first one. So depending on the value, you can quantify the skewness. Also, you can just plot the data, and you can check. For example, this is the first one whose value is 0.29. You can see the distribution. It is of course not Gaussian distribution, but yeah, it is near to Gaussian distribution. But for example, if you see the fourth one, let's see the fourth one. So in fourth one, we have observed this negatively skewed. So as you can see, it is negatively skewed. So in my next video, I will come on the different type of plots where I will explain more on the histogram. But for now, I will next move to the kurtosis. In kurtosis, what we see, if we have any huge peak in our data, it can be seen through kurtosis. If the value of kurtosis is greater than 3, that means you have a great peak or a greater value in your data set. If it is not, it is lower than 3, then your value are, that peak is, that a high peak is not there in your data set. For example, I will see the kurtosis of the first column. So I have observed that no, in my data set I haven't that you know that long, very high peak is not there. So we can just cross check it by uh, uh, the modifying my data set. I can put it here like a huge number, and I can put it all this as 0, just, and then I will save it, and then I will again extract it. Let's go back to the first, yes, this one. So now my A is, you can see there is a huge number. Let's check whether in kurtosis anything change we can see or not. Okay, oops, I think I have put many brackets. Okay, yeah, you can see its value is greater than 10. And if I plot the histogram first, you can see there is a very huge data peak. You can see the very huge data peak. So this is the kurtosis. I think one thing left out is the mode, if you are interested in mode. So as far as my knowledge, there is no function in R4 mode, but that's not a big deal because you can easily do it with a function table. So mode is basically that that particular number which comes maximum time in your data series. Okay, so in first column you can see I have two number which came twice. So mode of my date of my first column would be this one. So let's just put the function table, and then if we do the, we put first column, and you can see this will be the mode. And like if you have a large number of data, this is very small data set, I mean this is a dummy data set. Like if you have very large number of data, what you can do, you can just do this table function, and before this you can add one more function which is short, and then you can like do you can type it like a decreasing true, and you can see that I have arranged my data set in a such a way that uh, that that particular number will be shown first, which has maximum number of occurrence. So I have arranged it like this. So if I have large number of data set, I will able to see that particular number which have came in my data set most of the time. So likewise you can find mode also. Now I would like to say one very important thing who are beginner to ours. People are very confused that how we will know how which function has which command has in it, in that will be very confusing. For example, I work in R for few years, so maybe I know which function has which like how I will know that decreasing is there. So I will give two tips here. Whenever you are new to any function, just type interrogation sign, and then for example short, just hit enter. So there will be a help uh, tab where you will be able to see that there is a short function, and whatever the commands are there, it will be shown here, and description of that command, arguments, whatever arguments you have, and its description is explained very well in this help tab. So whenever you are new to any function, just type the uh, integration sign and then your function, hit enter, and just read it. You will be able to clearly understand what the function is, what are the arguments in it, what is the meaning of that argument. You will be able to understand it. And yes, and another thing is that for shortcut, of course, like if you write a function short, sorry, a function short, and then give the first bracket, and then hit tab button in your desktop or laptop, you will able to see the function that are in that the argument that are inbuilt in that function. So tab is a very useful button for those who are working in R. So yes, this is the two tips for those who are a beginner in art. So this is for this video, and in my next video I will come with different type of plottings when we are, I mean, new to any data sets, how we can see different type of plotting, like for box plot, bar plot, histogram, line plot, scatter plot, frequency distribution. So all this type of plot will be covered in my next video. And if you find this series interesting, if you find this video useful, share with your friends, colleagues, and like this video. Thank you for watching.